Welcome to a wild chemistry class. Make sure you have your protective gear on. Let's go. We have to be quiet so we don't spook them. We've managed to procure an interview with one of the wild chem students. Here she is. She's going to explain what they're doing.
We distilled 3% hydrogen peroxide by using a simple distillation apparatus. This involved using round bottoms, 2 round bottoms, one for the distillation flask and one for the collection, and a condensing tube along with, I can't laugh, along with attachments for the thermometer and 2 stands along with a heating mantle for the distillation round bottom.
They're preparing for a reaction. They're about to do an experiment. Let's go see what they're doing.
Today we reacted concentrated hydrogen peroxide and potassium iodine in an aqueous solution to form an excess of gas. We added soap to this mixture to be able to visualize the gas, as normally the gas would just escape and not be able to be seen. If we added the soap, it makes bubbles.
Hey Julie, what are you doing?
Doing some math. The first thing we had to do was find the correct amount of the soap, the hydrogen peroxide, and the potassium iodide that we had to use for this experiment. We based it off of Rutgers online experiment. Thank you. So, the first thing was that they originally suggested using 20 mils of 30% hydrogen peroxide. We only distilled ours from a 3% solution to 11%. So we're still using the same volumes, but just basing it now off of an 11% solution. So, and they also suggested using 33.2 grams of potassium iodide. So since we're only starting with this very small reaction, we're only going to be using 2.5 mils of hydrogen peroxide. So doing a ratio, we solve for X, and the amount of potassium iodide that we'll be having to use is 4.15 grams. We did the same thing for the soap and the water because the potassium iodide is going to be in a 2 molar solution. So we solved for water, and 12.5 mils of water will be used to create the 2 molar potassium iodide solution, and soap will be using 0.625 grams. And this is the culmination of all our hard work.
Well, it changed colors.
I'm really happy with this.
Wow, that's awesome.
This is the mechanism for Elephant Toothpaste. In this experiment, we catalyzed the breakdown of hydrogen peroxide in water using potassium iodide. We are not going to show how potassium iodide speeds up the reaction, but rather just talk about the breakdown of hydrogen peroxide. To demonstrate this reaction, we are going to start with hydrogen peroxide, H2O2. When hydrogen peroxide is exposed to heat or light, it starts to degrade. As this happens, the bonds between hydrogen and oxygen break, and the electrons from the bond get donated to the oxygen. This creates a negative oxygen and a positive hydrogen ion. The newly made HO2 molecule is not stable, and the negative oxygen forms another bond to the other oxygen. That oxygen then breaks the bond it has with hydrogen, donating its electrons. This creates another hydrogen ion, but a negative one. The result is O2, or oxygen gas in this case, and 2 hydrogen ions, one negative and one positive. To complete the subsequent steps, we must bring in another hydrogen peroxide. First, the oxygen from the negative hydrogen attacks the hydrogen peroxide. This forms a negative oxygen, and the oxygen then donates the electrons from the oxygen bond to another electron. This creates a negative OH ion, which then attacks the positive hydrogen. The result is 2 water molecules and 1 O2 molecule. With the help of potassium iodide, the reaction speeds up. With our addition of soap, the oxygen gas and water mixed with the soap and created bubbles.
Adding 3, 2, 1.
Anything? Oh, something?
Start going fast.
And there's the blue. Why we made green?
That was purple.
No, we added.
Well, there's a lot of yellow in the reaction.
Yeah,
There's like an orange.
and we added red and blue.
It's like lime sorbet.
So you're certainly getting a large volume of reaction now.
We just need to go quick.
So if we go too quick, then all of the
Should react faster. Faster, not super duper fast. Alright, Keegan, you're up.
Please light.
With all of the flasks they used so far, it looks like they're gonna go to the extreme.
Like that.
Oh, it started.
It's orange.
That is a
That is
lot.
just pouring out of there.
And it's going fast. You can see why they call it toothpaste though, like the way it's sort of falling on itself.